going to talk about the change of base formula today, and the change of base formula states that if you have log base a of b, you can rewrite it as log base c of b over log base c of a for any value of c. So you could rewrite this in a lot of different ways, and it can help you get logs into a situation that's easier to compute things. So we'll talk about why it works, and then we'll give some examples, and then we will talk about where it's useful. So let's say we have log base 2 of 8, log base 4 of 64, and log base 16 of 4096. Well, each of these things is actually pretty easy to compute if you understand how to rewrite them. So 8 is 2 to the third, 64 is 4 to the third, and 16 to the third is 4096. You can rewrite the exponents of the argument, or the inside part, as coefficients, and then we know that log base 2 of 2, log base 4 of 4, and log base 16 of 16 are all just 1. So the answers to each of these things is 3. So what we may notice is if the base and the argument are both taken to the same power, then the value of the logarithm remains the same. Now that may not have been as obvious unless we point this out, but notice that 4 is really 2 squared, and 64 is really 8 squared. So if I square the little number and square the big number, I ended up with the same answer. Notice that from the first one to the third one, 2 to the fourth is 16, and 8 to the fourth is 4096. So if I take the base and the argument, or the little number and the big number, and I take them both to the same power, then what ends up happening is the value of the logarithm remains the same. So all of these things we realized were equal to 3. So this helps lead us to the change of base formula, so we can rewrite logarithms in whatever base we want. So what if I wanted all of these things that we know the answer is 3? What if I wanted to rewrite them all in terms of base 2? So if I use the change of base formula, what I notice is that this is 6 and this is 2. This is 12 because 4096 is actually 2 to the 12th, and 12 over 4 all gives us 3. So that leads us to the change of base formula, because we know that all 3 of these things are the same, and if we rewrite them in such a way where I use this base 2, it ends up working out. So what is the change of base formula? Well, we already talked about it at the beginning, but log base a of b is equal to log base c of b over log base c of a. So that's true for any type of c. So I just have a random example at the bottom. Log base 5 of 7. I can rewrite it as log of 7 over log of 5 in whatever bases I want. So I could choose base 6, I could choose base 2, I could choose base 23, I could choose base 100. I could actually choose the natural log also. So I could say natural log of 7 over natural log of 5. All of these things are equal to log base 5 of 7. If I typed all of these things in the calculator, I would get the exact same numerical answer for all of them. When is this helpful? Well, it's helpful when we evaluate something confusing. So if I have log base 1/9 of 243, I can rewrite both of those in terms of log base 3. So I could say log base 3 of 243 divided by log base 3 of 1/9. And the reason I would choose 3 is because each of these are powers of 3. So I end up with the numerator being 5 and the denominator being -2. So my answer is -5/2. Now I could get that in other ways, but this is a pretty easy way and a very helpful way to use the change of base formula. What if I have all of these logs multiplied together? Well, that's pretty confusing. I can't use the properties of logs where when I have a plus sign in between them, I can combine the insides because number one, I don't have a plus sign anywhere. And number two, the bases are different. So what I might do is I might rewrite all of these in terms of the same base. And I noticed that I had a 4 and a 2 and a 4 and a 16. So I saw a lot of things that had multiples of 2 or 2 to the power of something. And so I decided to use log base 2. And so I rewrote all of these in terms of log base 2. Log base 2 of 4 is 2. Log base 2 of 2 is 1. Log base 2 of 4 is 2. Log base 2 of 16 is 4. So 2 times 2 divided by 4, all of those cancel. I also notice that I had a log base 2 of 5 in both the top and the bottom after I rewrite them with the change of base formula. Now, if I used any base, I would have ended up with something that would cancel out, because let's say I used log base 12. Log base 12 of 5 and log base 12 of 5 still would have canceled. So as long as I'm choosing the same base for the top and bottom repeatedly, it's going to be a really nice, easy thing to cancel out. And the same thing with the log base 2 of 7s. So then all I'm left with is a log base 2 of 11 over a log base 2 of 3, and then times 1, which I don't really need. So I end up with log base 2 of 11 over log base 2 of 3, which I can then rewrite using the change of base formula backwards to log base 3 of 11. Because if I can take this and write it this way, it makes sense that I can take this and write it the other way. So one way that the change of base formula is helpful is evaluating something confusing. One other way that it's helpful is condensing something with unlike bases. So this is one of those problems where we have plus and minus signs, and we really like to combine things. So let's say the problem says condense, and I want to get it into one log. The change of base formula might be helpful because these bases are not the same. The good news is all of these bases are powers of 2, so I might rewrite these as powers of 2. So I'm going to rewrite them all using the change of base formula. And then notice that all of these denominators, since all of the bases originally were powers of 2, all of these are going to work out really nice for me. So log base 2 of 8 is 3, log base 2 of 4 is 2, and so on. The other thing I can do is I can take this 3 exponent with the x cubed and rewrite it as a coefficient. Now, the last thing I might want to do before I start combining things is using more properties of logs. So this 2x and this 4x, I can expand, because if I have multiplication on the inside of a log, multiplication in the argument, I can rewrite it with a plus sign on the outside as a coefficient. And then the last thing I'm going to do is rewrite these just to make it a little bit easier to add. So I'm going to take all of these coefficients that have denominators and rewrite them as fractions that make it easier to add. So I have two numbers that are just numbers. So I have 1/3 minus 4/5. And then I have these other log base 2 of x's, which I can just add those coefficients. So 1/3 plus 3/2 minus 2/5 minus 1. So after I add all of those, I end up with the 7/15 disappeared. But I have 13/30 log base 2 of x, and that comes from just adding and subtracting all of these coefficients. And then minus 7/15, that comes from the 1/3 minus 4/5. And then since the problem's directions were condensed, I'm going to take the coefficient and turn it into an exponent on the inside, the exponent of the argument. And so those are some uses of the change of base formula. One more reminder about what the change of base formula is. I can take log base A of B and rewrite it as log base whatever I want of B over log base whatever I want of A.